This video is brought to you by Sporlan, quality, integrity, and tradition. Alright, today we have a Hoshizaki ice machine that's not working. So this side's running. Don't know if it's running right, but the call was no ice. You can see it's really low in there. And this is a bunch of store-bought ice. So I walk up, the right machine is not working. We do have power switches right here. They both look to be on. The first thing we're going to do on this Hoshi machine is we're going to start by checking this bin thermostat. Bin thermostat turns the machine on and off. It's that guy right there. So we're going to check to see if that has an open circuit. So all that I need to do is get right down in here, hopefully without shorting anything out. Okay, and we have no voltage present, so either it has no voltage at all or it's closed. Because that is a switch. It's just a temperature controller is all that it is. So what we'll do is we'll pull one leg off. We're testing to ground, so the odds are we do have the correct voltage, but we need to go ahead and verify that we have full 208 volt single phase coming into this machine, because that's what it is. So let me find the connectors and we'll check that. So I got back here to the incoming power, and we can confirm that we have 205 volts coming to the machine. This is a single phase machine, so that is correct. So why do we have no LED lights on the board and the toggle switch is not powering it on? Next thing I'm going to do is flip it to the wash position. Nothing happens. Okay, so it's almost like power's not making it to this. Let's go ahead and check this fuse right here, because there is a fuse, and we'll see if that guy is open. In doing this, looking up here, that fuse has a burnt terminal on it. Don't know if that's a problem or not. Let's see if I can do this safely. I've switched to my circuit board leads. We have 118 volts across the fuse. I think we might have a blown fuse on this guy. Let's go ahead and pull that out. We'll turn this off. That's the power switch. The reason why I know that is because the other machine didn't shut off. I'm still not going to stick my hands in there, but turned it off here, turned it off here. We'll verify voltage. I dropped the fuse, but I did check it before I did. I broke it, but it is a 10 amp glass fuse. You can see the remnants of it right there, but it's bad. The fuse is bad. So we need to figure out what caused the fuse to blow. Now we do see a loose electrical connection right here. These fuse blocks have been known to go bad, and then there also is some overheating back here on this, back in there too, on that contactor. So those both are suspect. All right, I marked all the wires and I pulled this relay out right here, and it the points in it, the spot where the contacts make connection, it's hard for you guys to see, but there's lots of arcing going on in there. And it doesn't look good. I can see it like right in there. Really difficult for you guys to see, but it's got lots of arcing. You can kind of see it right there. So that could be part of the problem. We don't know if that's the only problem, but we know that these two wires were very discolored, and you can see that the terminal is very discolored, and also on the fuse connector too. So let's get on replacing those and then move on forward from there. I'm starting down the path of replacing burnt wires, and you have to pay attention when you have a bad connector like that. Can be from a loose connection, can be from a lot of things, but the wire is brittle and hard. And as I cut it, I'm noticing that it's burnt. So I'm having to cut off quite a bit. And then as I'm tracing it back, I notice it's burnt back there on the capacitor too. So it's just kind of, you just got to keep following it, replacing all the bad sections of wire, check the components that they're plugged into. Just be thorough. Big picture stuff here, right? Always trying to look at the big picture. Looking at, I thought I saw a wire here a few minutes ago that had a burn mark on it, like on the actual wire. I don't know, we'll keep going. I'm going to use a contactor for now because I don't have their relay. It's a 120 volt contactor, 40 amp, so this will be plenty big enough. It's really common, this fuse holder is kind of jacked up. This little piece pulls out and it shouldn't. Also, it takes a smaller connector, so you got to make sure you have those tiny ones. So I can't put the insulated ones on because it's not a standard connector size, it's much smaller. Alright, so I've replaced everything burnt, everything's back together. I guess we're gonna try. I tested for shorts to ground. I didn't find anything. I'll do it again just to be safe, but probably just about ready. So power comes out of this, runs through the bin control, comes back, and goes into the board and gives it power and everything. So essentially we had no power coming out of this because of the blown fuse, but then we had all the burnt wires, so we replaced all those too. I checked for direct shorts to ground on, that's all the control circuit. Nothing. So 1, 2, 3, please don't blow up. I think I did everything right. Let's do the water pump first. Water pump runs. So I put it into wash mode, so we're testing the water pump circuit. Don't see any issues there. Let me get a clamp meter on there real quick. Water pump doesn't look like a problem. Okay. We have control voltage, and it should start up in a harvest. See if we get any fireworks coming out of this thing. It's in a delay. It's in a water fill. It's going to fill till the float satisfies. Plus on the newer machines, I think it has a timer. So it's not just looking for a direct float to close. And then we're just going to wait for the startup sequence. These machines on startup, they're actually going to overfill, and it's going to fill to the point that water starts going out this drain, out through this check valve. It's going to, well, it's overflowing on the standpipe actually, on the back side of that, and it's not going through the check valve yet. That happens when the pump turns on and runs it backwards. But it overflows the standpipe on the inside of that, runs down the drain and creates a siphon from the bottom of the sump to try to remove any sediment. Now it's not going to remove it all, but it removes some of it. Okay? Compressor started up. We're in hot gas defrost now. So the hot gas valve back there opened up, and it's going to run until this orange thermistor wire right here senses a temperature on the returning suction line coming out the bottom. It looks at one of these and it looks for a temperature, a specific resistance value based on the thermistor wrapped around or put on the line basically. And then once it does that, I believe it starts a timer again, and then it'll go into the freeze mode once it knows that the evaporator, that's how it assumes that the evaporator is clear of ice, is by the thermistor temperature. Read the instructions. These newer machines, there's a few new steps in there. They used to be really simple. They added a few timers and different things in them now. Still basic principle though. I'm watching the current of the control wire, the one that the fuse was on, running at about 3 amps. That's not bad. Gotta be careful. We don't want it to pull down on that fuse block, but we're just going to watch it, making sure we're getting nowhere near 10 amps because that was a 10 amps glass fuse on that guy. So see it right there, 10 amps. So I will leave a few of those for the next guy. Always keep extras of those. And we're just going to watch it go through its cycle. And with the water pump running, we're now at 4 amps. This is all the 115 volt circuit. Still no issues there. Now another thing that can happen too is little pieces of stuff can get stuck in that water pump, cause it to lock up. I'm not seeing any broken pieces of this cube guide, but we're going to keep looking and watching. We're going to watch this guy make ice. Alright, this guy is harvesting ice right now, so that's a good sign. We're still under current. The highest I've seen it go is 4 amps. What do I think caused this? Well, I still want to investigate this water pump. In a minute, we're going to drain all the water out and investigate the impeller, make sure there's nothing stuck in there. But I think that this fuse block was the problem. These are known to have issues. There was some white powder on the top where I think it was just overheating because of a bad connection in the back. Now, I kind of temporarily fixed it, but I think that was the initial problem. And then that led to the burnt wires, but the contactor itself, I think that was just normal wear and tear that it was pitted. But yeah, so we're just waiting now. Little trick on these is when the machine's off, pull this tube. As long as it's clean water, point it down into the bin, hold the hose with your left hand, and flip the switch to wash, and you'll pump out all the water. You can drain it too, but this way you're not contaminating anything. And then that way I can pull the pump out here in just a sec. the most part, got all the water out of the sump, and then now we can just pull this guy, pull the pump out. There'll be some residual water, but nothing bad, and then we can inspect the impeller. Got the pump out, nothing going on in there. A little dirty on the back, little rust on the bottom. Don't see any issues, nothing stuck in there, so that's a good sign. So let's put it back together. You also want to know something funny. These Hoshizaki machines are notorious for these pumps overamping. There's never anything wrong. On the pump, it specifically says 0.85 amps, but on the right here, it says that the pump can run, where's it at? 1.2 amps. Right there. Always, these things always, so don't just assume because it says 0.85 on here if there's anything wrong, as long as it's under the 1.2. But that just blows my mind. But yeah, so far everything's looking good. I put it all back together. I was just testing the pump. We're gonna put it back into a freeze cycle. We're gonna order that fuse block and tell the customer to keep an eye on it, and then we'll follow up on it when we get the fuse block. All right, I am back today. I've already turned off the machine. It's full of ice, been working good since I left last time. This side is full too. They haven't been running out of ice, so that's been a plus. So I already shut off power right here. Open this up, we're gonna get that fuse block changed out. Never been a huge fan of these, but so I already put a fuse in there. This one though, the biggest problem is that this piece right here is not staying in there, and it's making a bad connection. So in there, it's not really bent over like it should be, it's just deformed. So this is the new one. We'll put it back in there. Everything else looks good. No more new burnt wires or anything. So customer's been happy since I fixed all the burnt stuff last time. And we're assuming that since they haven't had any more problems, that I fixed the problem by changing the contactor and replacing the burnt wires and making temporary repair to the existing fuse holder. So, all right, let's get it all put back together and watch it make ice. So it cleared away all the ice, but you'll sometimes have to heat up the bulb to get it. Actually, I have it off. There, it already heated up. So when I first did it, it didn't beep. If it beeps, then the bin stat is open. So, all right. There's that, or closed, or whatever it does. It would be open, actually. No, closed. It opens when it turns off. It closes when it heats up. So it's just a temperature controller. So now we're gonna watch a full batch of ice, make sure everything's good, but we should be good to go. It's funny, I used to work on so many Hoshizaki ice machines. It used to be the #1 ice machine in restaurants in my area was Hoshizaki machines. I used to work on the old DSSU, which were the 502 ones. Those things had stainless steel cube guides that never broke. And the funny thing is now we've gone to the plastic cube guides that break and cause water pump failures all the time. So you do the math, right? You could put that one together in your head. But yeah, Hoshizaki's actually used to have a stainless steel cube guide, which a lot of people have asked, like, why don't they do that? That would be a great solution. It's just because there's so much design work that goes into designing those. But yeah, 100%, they used to have them on the old DSSU models. Yeah, I've been working on them for a long time. The newer models, you know, they're still a good machine, good-ish. They have a real issue with evaporator plates right now. I think they're kind of getting that sorted, but the damage is still being realized. How many evaporator plates had failed on the Hoshizakis? It's been insane. I still have a restaurant that has a failed evaporator plate. It's out of warranty, and the machine's still working, so the customer hasn't wanted to fix it because they're like, oh, it's still making ice. It's just reduced capacity. But, you know, when you operate a machine with a failed evaporator plate, for a service technician, it's a nightmare, because if the machine's not working, is it just the lack of capacity because of the failed evaporator plate that's separated, or is there something else wrong? And it's always difficult to diagnose when you have one that's known to have a failed evaporator plate. But anyways, I digress. On this one right here, you know, I initially walked up, you guys saw my procedure. I mean, the machine wasn't running. I verified the bin stat wasn't open, and then I found a bad fuse, right? And the bad fuse, I think, again, I'm making an educated guess, okay? Because I checked everything else out. The machine seemed to be working fine. The only issue I could find was some burnt electrical connections, which to me indicate loose connections, okay? So I went ahead and repaired those loose connections, repaired the burnt wires, cut them back, re-spliced them, you know, did what I had to do. Put in a new contactor, and also ordered a new fuse holder and replaced that. Those fuse holders are just trash. I would love a better one, but I just went back with the Hoshizaki one. They're not that expensive, but still, it's just kind of silly. Something like that takes down the machine, you know? Other than that, I couldn't find anything else wrong. So the initial time when I went out there was on August 19th, and then when I returned was on August 26th. So just a little under 7 days, and they hadn't had any more problems. So, you know, replaced it and everything's good. It's now August 27th. Everything's good. No issues at this time. So we just told the customer to keep an eye on it. You know, I can't go into these restaurants and be like, this is your problem 100% of the time, because sometimes it's not that obvious. Sometimes you have to start unpacking things, you know, diving through issues. And so that's why it becomes so difficult when customers don't do, you know, normal routine maintenance. Now, in this case, these machines, they weren't that dirty, so that wasn't an issue. But when you have customers that do reactive maintenance, that can get a little tricky, because oftentimes you need to realize, like, hey, this thing needs to be cleaned before I can diagnose it. You know, let's not just go in there and try to put a Band-Aid on it, because then you're trying to solve problems with a dirty machine, you know, and it just gets a little difficult. But this situation, the machine wasn't dirty, was able to go through some troubleshooting steps, found what I think to be the problem, but who knows? And again, I gave the customer a disclaimer. I mean, everything else is working. The only thing I could find was this. I repaired that, and let's just see what happens, you know, give it some time. So hopefully they'll be satisfied with that. And that's it. I really appreciate you making it to the end of the video. Thank you so very much for watching. If you haven't already, please consider subscribing to the YouTube channel. Definitely helps out the channel. There's a couple different ways to support the channel if you're interested in doing so. You know, the easiest way to support this channel is literally just watch the videos from beginning to end. That really is the easiest way. You can also go to my website, hvacrvideos.com, where we have merchandise available, hats, some sweatshirts, some t-shirts left, lots of different styles. Check it out. Again, hvacrvideos.com. You can also support the channel via PayPal, Patreon, or YouTube channel memberships. As a YouTube channel member, it's a monthly commitment that you make, and then you usually get early access to the videos. Now, I'm not saying you're going to get like a week's access. I'm not guaranteeing anything. But like, for instance, I'm going to finish this video today. My video is not going to post until Thursday. Today's Tuesday, right? So potentially they'll get early access if I get it finished and uploaded, the people that are channel members, right? So just one of those perks. I wish I could do it for Patreon, but it's more of a pain in the butt, and it's YouTube, you know, they want you to use their YouTube channel thing so they can take their crazy fees and all that stuff. But anyways, we're going into a tangent as usual. One last way to support the channel is by going to TrueTechTools.com. TrueTechTools.com is an online tool website. I have an affiliate program set up with them. I get a good majority of my tools from their website. So if you see anything you like in my videos, there's a very good chance I got it from TrueTech Tools. Go to their website, check it out. At checkout, when you get all checked out, put things in your cart, use my offer code, big picture, one word. If you put that in checkout on majority of the items on their website, you'll get an 8% discount. I get a small commission from that. Another great way to help support the channel. Okay. I really appreciate you guys making it to the end. Thank you so very much. And we will catch you on the next one.